All right, so here we are. We are up to we're going to do chapter 3 and 4 today because they're pretty short to talk about functions. And then I've got a couple of demonstrations. So to do those, I want to get to the Colab books. So I go to the textbook and I scroll down here to the notebooks, and here's the chapter 3 notebook. All right, so it's running in Google Colab. This is logged into one of my Google accounts. So I run this preliminary stuff that prepares it, and it warns me that the notebook is not authored by Google, which is fine. I'm going to run it anyway. By the way, this is running in a browser. It's running in a Docker container somewhere on a Google server. So even if there was malware in this, I'm not too afraid. I don't think it could steal data from my local system. The only thing I suppose it could possibly do is steal something from this Google account, but this is not even my main Google account I used for Gmail or anything. It's a throwaway account, so that's why I feel pretty safe running something here. It came from a textbook author, and I don't imagine it's malicious, but I wouldn't be very afraid to analyze malware by running it in a Google Colab instance. It's a pretty isolated environment. I don't think it would be able to spread onto my machine or anything. Anyway, so we're talking about functions. We already used a few like int and float before, and some that come in with the math module. Now we're going to define our own function. So let me make this a little bigger. Here's a function that will print some lyrics from Monty Python. It's just a couple of print statements. If you run this, there's no output because all that does is define the function. It doesn't run it yet. Down here is where you run it. And that function has no parameters. Now I'm interested to hear, if you do this, yeah, it's going to show you the function. This is one way to print the function itself, showing something about its structure, but this is not the way to run it. To run it, you have to put the open and close parentheses on it. So I've never done this actually, just refer to a function name without the open and close parentheses because I want to run it. This is where you run it, and now you get the output of the function. Prints some lines from a Monty Python song. So there are parameters that go in. When you define it, you can put a parameter here, and then it will print it. So this one, instead of always printing those same lyrics, will print whatever string you pass it twice. So you define it. And now if you call Dennis Moore, it'll print Dennis Moore, Dennis Moore. So that's a simple example. And so you could also do this. You could define a string called Dennis Moore and execute 2 print statements to achieve the same thing, and that would be fine. The reason you would write a function to do this is because this is something you're going to do over and over and over. If there's something you do only once, there's not much reason to make a function out of it. You normally do that for something that you're going to repeat over and over. And in your program design, it is a very good design feature to break it into little functions and write and troubleshoot the small functions one by one. That's much more likely to work than having a big, strong block of code and trying to debug it. Making it in small functions isolates problems and makes it easy to test it. So you can use a variable as an argument, print twice. You don't have to put the literal variable string here. You can put it in a variable and pass it up. All right, so when you call a function, here's another Monty Python song. So we're going to start with a function which takes 2 parameters. This will repeat a word n times. And so it will just print word times n. Word is a string. You can multiply a string by an integer, and it will just repeat that word over and over. So if I give it spam, comma, space, and run it, then it'll do spam, 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 just repeating it over and over. All right, so if I want to do repeat, I can define a new function that will print something twice. It takes no parameters. It will repeat spam twice. And I'm getting bothered by the fact that this spam is not in quotes. That is bothering. If it was in quotes, I would understand that. This bothers me. Let's see if this works. Call first 2 lines. It does work. All right, now I must confess I do not understand why this works. Because the variable spam, oh here, okay, the variable spam was defined up here. However, I didn't think that variable would propagate into a function unless you declared it as global. So that is interesting. So if I made this spam2, if it was a new variable, and then called it, it would not work. Right, spam2 is not defined. That is very interesting, and it's a subtlety of Python that I don't completely understand. You define spam up here. I thought this was the whole point of defining variables as global, is that they would be excited, but apparently you can define a normal variable outside a function and refer to it inside a function, and it will recognize it. That's a surprise to me. All right. Anyway, all right. So now we have another function which uses repeat, repeats a couple of lines. That defines the last 3 lines, and when you run it, it'll print those. All right. And so there's a function that will do it all. I do not like the style here. No, I'm not in Zoom, I'm just in Twitch right now. I'll get in Zoom at 7:30 if people want me to. Anyway, so this, I do not like this style because it's using this variable spam and it didn't pass it in. I would pass in the variable. It is a strange thing for it to know this quantity and have it defined here, isolated from the function. That's a strange way to do it, and I'm surprised it works at all, and I find it unnecessarily confusing. Anyway, I would have passed it in a function. Anyway, so you can use a for statement. This is extremely useful. For I in range 2, that will start, a range of 2 will count from 0 up to but not including 2. So it'll do 0 and 1. It'll run for I equals 0 and I equals 1. So this will print, and so there it prints 0 and 1. Notice the colon and the indentation. When you have a for statement or any statement that refers to a block of statements after it, you put in a colon and then you indent the next line, and all the lines that are in the block of code should be indented the same way. So here we're going to print a verse number and then the verse and then a blank line. So there you go. All right. And of course, you can put for loops inside a function. You can put anything inside a function. You can put outside of a function. So this will now print n verses for n and call the function. So this is quite a few layers deep in calling functions. All right. And this is just what I was talking about earlier. Variables and parameters are local. So here I define something that will take 2 arguments, concatenate them, and print the result twice. So it'll take 2 strings, part 1 and part 2, add them together, and print that twice. And so there are local variables called part 1 and part 2, and for that matter, cat. Cat is the variable that exists only while you're inside here. And so there you can print out some things. So this local variable cat exists only during the function and is destroyed when you leave the function. So if you try to print it outside the function, you will get a name error. Now the expect line is not really necessary here. The point of that is, if I had other lines after this in the same block of code, they would not be executed normally. It would stop executing as soon as it hits an error, but this expect tells it to keep on executing the rest of them. When there's only 1 line here, it's not that important to put in the expect. Anyway, so you can make a stack diagram. I think we've seen these before. They like these things. You make a diagram with arrows pointing to values. So in the main routine, you have line 1 and line 2 defined. In cat twice, you have parameters coming in and a local variable and other variables here. So this is a way to list the variables inside each function and what they have. Anyway, there's also tracebacks. If you turn on more advanced error reporting with X mode verbose in Jupyter, then it'll give you a sort of stack trace when something crashes. So here we're going to get a name error, and it's going to give you exactly where the name error happened, and it happened inside this function, and inside that function I tried to print cat. So the cat was defined, this function called print twice, and this is where the error occurred. Anyway, the stack traces are somewhat useful, although a little confusing to read. Anyway, here just describe the situation with functions. Functions do make your code much more sustainable. It makes it easier to reuse code. You can write a function and reuse it, and it makes it a lot easier to write and debug, to have small little things you do one at a time and write functions for them instead of having a big block of spaghetti code. So let me try a Kahoot. There should be one for chapter 3. This should do it. right, chapter 3. I may have no takers today for the cahoots. I'll wait a bit longer and then abandon them. All right, let me stop this video for chapter 2.